So here in scene 6, another scene I've put together largely from the libraries that Horo's organised for our content. So we've got bodies and deep space objects. We've got these that are actually volumetric clouds and these that are 2D images produced, I'm guessing, in a similar way to the one I've shown you, although Horo set all this up and organised it because I'm not very good at organising things. And star clusters and star backdrops, which don't really show up on these thumbnails because they're only little pinpoints of light. I can just see them on here, and probably when they've been compressed by Camtasia Studio they'll have vanished altogether. So there you go, those are what the libraries look like. I've adapted things somewhat in the scenes here and there, but hopefully I'll get around to showing you how that's done. I've touched upon it with talking about the face, but in this example what I thought I would do is show you how to capture this nebula, which I've just explained all this in this scene. We've got the camera in the centre down here, and then a corona, which is this nebula effect wrapped around the camera, then a 2D nebula and a planet assembly just there, and behind that we've got another light source, sun, a sun glow colour, and this distant light source, and also another sun glow, which I just copied and pasted like so and put back here to add a bit of an extra glow behind this nebula. But what I want to do is just get rid of all this stuff here and have this corona, and I'll get a bit closer in so you can see what's happening. We'll make sure this perspective camera is placed at the origin. I won't worry about the tilt so much, and we'll also position the corona at the origin. And what I plan to do is capture, I can't do it unless I unlock that, capture this as a 360 degree projection using the built-in cylindrical projection in Bryce. If you were to spherical map it, you'd have a perfect projection, then you could wrap it on a sphere and there wouldn't be any joints. And Horo and I have a spherical mapper product in the DAS store if you want to go down that route, but I'll just show you a way of doing it that sort of works-ish. There'll be a bit of distortion at the poles. Right, so to set up the document set up to a 2:1 aspect ratio, and really you want to be rendering this, I'll just give it a render now, at the highest resolution you could be patient enough to produce. The other thing to note is that the stars, when they're anti-aliased, will, because of their small size, tend to vanish, and the anti-aliasing pass will take a while. So what we could do is save ourselves that trauma and just turn the anti-aliasing off. And we've also got this issue with the glowing horizon, which, you know, could be used for a special effect perhaps in a later video, but for now we don't want it. So what I'm going to do is create a torus, position that at the world origin, rotate it round so that it's lying flat, enlarge it so that it's bigger than our volume material, squash it down the bit I'm guessing about there, modify the material so it's fully black, and then when we render it, it should have covered the horizon up. It'll have also covered up stars in that region, but that probably won't be that noticeable. The other thing we can do is disable the sunlight. We don't need any sun or shadow casting or anything like that, because we're just capturing the self-glowing nebula. Right, lost the word there. Okay, some things to consider here. Right, I'll set this render up so it's rendering at a reasonably large size for us, and point out that this, because this is going to go all the way around, we're going to apply it not to a 2D face, which we were doing in the previous videos, but to a sphere or cylinder, something that allows a full 360 degree projection. And this is great because it means that you can rotate that sphere around and get different effects within the cloud, look at different areas of the cloud. The disadvantage is it has to be so much higher resolution than a 2D face that you capture. A 2D face that you capture can be just the same resolution as the scene that it's going to be transferred into, but this, when we have our field of view, I can draw a square over this, you might only be looking at that portion of it. So at that case you could only do a render really at that size, because if you get too close you'll see pixelation or blurring and it won't look so good, and the stars won't look so sharp. So the drawback of this approach, capturing a full 360 or spherical mapping if you were to use a spherical mapper, is that you need to capture at a much higher resolution. You don't have to sit and watch it do the rendering. In fact, I'm going to pause the video in a minute and let it get on with it. but it does mean it's going to take time. Once you've done it, you've got the advantage of something you can reuse in other scenes and just drop straight in, and you'll get a nice effect, and you can turn it whichever way you want. And if there are anything reflective in the scene that might look outside or other parts of the nebula, other parts of the image, then you've captured that. Whereas with a 2D face, if you've got a 2D face in a scene, like suppose you got a planet on a 2D face, but it was only half the planet, so the other half wasn't there, and you had a shiny reflective spaceship in the scene, for example, could be possible, and you saw the reflection on that. If it reflected the planet, you'd see that the planet was only an image and half of it was missing if that was outside the frame of the image. So, you know, these shortcuts are of limited use depending on the application, and then you have to find workarounds. So in that case with the planet, you might have to capture the entire planet even though you weren't showing the entire planet, just in case something reflective reflected that bit of the planet. Likewise, if you've got water surfaces, so we're looking at a water planet, then you want to make sure that any 2D frames weren't visible, the edges of the frames weren't visible in the water. So there's a problem with the picked interpolation mode. If you had a bright side to one side of the frame, like a planet, if it was cut in half, then the other half of the planet would be interpolated over to the other edge, so you'd have to turn it off. Anyway, I have explained these somewhat in other videos, so I will pause the video at this point and we will return to this in half an hour's time when it's finished rendering. Okay. So, there you go, that took some rendering, but hopefully it's going to be worthwhile. What I'm going to do now is, oops, press escape, file and export image, and give this an appropriate name. What we've got to now, background 5 by the looks of it. Hopefully that won't overwrite another. Nope, that's okay. So now that's been saved, I can revert to saved for this file and get rid of this initial nebula. I'm going to replace it and modify the material, reset it to default grey, pop a blob in diffuse, make it a picture. You can just go to the editor here and load in the file that I've just saved, which is here, which will be quite large. Check out of there. Now it's created a sinusoidal mapping mode, which is not that convenient. Let's try spherical and set it to additive, so we've got no shadow casting problems. And instead of using diffuse, I'm going to use ambient to make it self-illuminating. Check out of there, and then okay, right, so this is where the pole is, and I did mention because it wasn't a proper spherical map there would be some distortion there. So if I roll this around, oh, its origin's in a weird place, I can adjust that. I can get the, if I reset all the origins to 0, it'll fix the issue with the origin being in an odd place. That's presumably because this is loaded in from the library. So I'll just drop that down to 0, and now hopefully if I can rotate it round so we're not looking at either of the poles but somewhere in the middle, we'll have a decent effect. Now the nebula could probably do with being outside that planet, so if I just enlarge this now, so because it's just a surface, it's no longer a 3D shape, I can pop that outside the scope of that planet. And then if I want to change it, if I go to object space, if I rotate it along its equator, I won't see any of the distortion at the poles, and I can just pick out an appropriate, see, something like that perhaps. And as I was explaining, because this is a proper 360 degree, I can widen the field of view and there shouldn't be any issues. Just see a little bit of a line in there. I wonder if it's clipping into some 2D object. It looks like it is. So that's just to be aware of that. You don't want these things colliding, otherwise it'll create artifacts within your scene. So there you go. That was just that glow effect was clipping into the surface. It's still there. You can just make it out. Possibly it won't render. So I'll just move that out of the way. See, that's just that glow. Oh no, it's that nebula there. Oh, that's okay. Move that back and rotate it round and enlarge it. There we go. Let's put that in there. So I've just moved things out. Just don't want 2D surfaces with the images projected on them colliding, because they will interfere with one another. So there you go. That's a way of capturing a 360 degree panorama and then applying it to a sphere. If you don't want the distortion at the poles, then the spherical mapper is the answer to that, which is a product that Horo and I have made and is at it's at the DAZ 3D store. Okay then, I hope you found that interesting, and you'll utilise this effect in your own scenes. Cheers now.